Can you all see my screen?
Yes.
All righty. So my name is Liam Dunsmore. I'm a project engineering co-op here at the Shafter Shingle residential site. My manager is Arnold Alvarado. Quick agenda for the presentation. So we're going to do a quick introduction about who I am, what I do, and then we'll go through some of the major projects I've worked on, and then a brief summary of some of the smaller projects and key takeaways I've gotten from this experience. So about me, I'm from Atascadero, California, a small town about 2 hours west of Bakersfield. I'm a fifth year at Cal Poly San Luis Obispo studying mechanical engineering. We're graduating in March of 2026, which we're very excited for. A lot of hard work. Some personal interests of mine include cycling, cooking, engine building, and reading. That photo there in the middle, that is actually a ride we did as a group of coworkers in October called the Kern County Spooktacular. It's a 52-mile bike ride to the hills of Bakersfield. We did that with Kevin, Mark, Christian, and Matthew, our previous co-op. That was a really fun experience. Some great team bonding outside of work there. So the first project that I worked on was the Fines Drum sliding wall. So this was a forced suggestion from Alan, one of our production supervisors. So a bit of background on why we did this. So originally, or I guess some more even further back along, so our fines drum, the sheet comes along and almost does pretty much a 180 on the line right there behind the fines drum. And as it does that, loose granules and asphalt get kicked up off the sheet and hit this wall, and you get buildups. And after a while, those buildups can actually touch the web and rub off some of the granules, which is something that we don't want. So before, with the fixed wall that didn't move, operators had to reach in with a large scraper and actually reach into the machine while we were either going line thread or during downtime to clean it off, which is unsafe, impractical. And if you're running at full speed and you have a large buildup, you either have to slow down or stop the line to get in there, which is not really what we want to do. So with this design, we have a sliding wall that operators can easily pull out and remove. They can set it aside, clean it where they want to, clean it with whatever tools they need to, whether they want to use a pneumatic air chisel or hand tools. They have the freedoms there because they can move it and do what they want, and then easily slide it back into place without having to reach into the machine and put themselves in a precarious situation. This is also a project that I assembled, worked on. There's a picture of me doing some welding onto it, so that was really fun. Next project is the ACO unload rain cover. This is also a forced suggestion from Phil, one of our ACO operators. I talked a lot with him about the design requirements for this. This was a project that, so a bit of background again, why we do this. So this covers the asphalt strainers in our ACO unload yard. So when trucks come and unload asphalt into our plant, sometimes you get a dirty truck, sometimes you get dirty asphalt and get some chunks in there. So we have strainers that the operators can open up and clean out. So particularly during rainstorms, we have issues where the asphalt will pop and splatter because, cold water and hot asphalt, it's not a good mix. So this rain cover keeps our ACO team safe while they clean these strainers in the rain. They clean them once a shift. And so if there's a rainstorm, they got to clean it. They got a nice little cover to get under there and do what they need to do without being in an unsafe and unpredictable environment. So yeah, and I really appreciate the feedback from the ACO team that I got while designing this project. And as well, I want to thank Isaac and Braulio for helping me fabricate this. That was amazing as well. Here's some pictures of that project. So on the far left side, I've got the before. There's nothing there. In the middle, we have kind of midway through the installation, we got the frame up. And on the far right, it's the completed structure with the corrugated roofing and the siding to keep all the rain out. Next project is silo plating, phase 4, AFCE 253401. This isn't an AFCE that I wrote, but this is a project that I helped my manager continue forward with. So originally this was a project that was organized and run by Gary Durham, a temporary project engineer. When his contract expired, I stepped in to take over this role. So a bit of background. Our silos, they contain all of our granules, and the granules run through them. Eventually, due to the constant abrasion, the walls will thin out and we have to weld in reinforcement plating. So we have PCL contractor come in to do that. So The silos being a confined space and they're doing welding. We have a lot of permits there. So we have a hot work permit, confined space permit. Obviously every morning a pre-job brief, get those signed off by our ERT and our managers. And also we had to work heavily with our maintenance and production teams to get silos emptied out and decommissioned, recommissioning a completed silo, the permits to do that, the return to service permits, hazardous permits for breaking lines, etc. This was a great exercise in project management and communication, communicating with multiple teams, multiple different contractors to organize when scaffolding goes in, when we need our confined space rescue team on site, when the welding can begin, when the hot work can begin. And this picture is a great example of some of that communication. So PCL has to bring in the plates. How do they do that? They got to get that to that upper level. So they have to bring a crane in. And that requires communicating with our granular unload team to make sure that we got the tracks clear and we can get PCL in there to do what they need to do and make sure that they're doing so safely and consciously of our plant and not just moving around unnoticed. Yeah, it's a great exercise in project management that I really enjoyed. So next project, this is actually an AFCE that I wrote and designed. This is our Linmont splice ejectors, AFCE 253408. A little bit of background. Currently, our splice ejectors are outdated and obsolete linear actuators. It's in our laminator section, so when we get reject shingles that come through, operators can hit a button, linear actuators actuate and direct the shingles down to a trash hopper. So with this project, I worked extensively with our regional and plant control specialists, Rusty, Aaron, KJ, and Dalton, to spec the drive equipment, the motors, cabling, any sort of connectors, figure out how do we make sure that the motor and gearbox combination that we spec out currently matches or exceeds the requirements needed by the current linear actuators, and making sure that we don't get something and spend a ton of money on something that's not going to work. Doing that, and that was amazing to work with them and learn a bit more on the control side and the electrical and understand what goes into speccing equipment and the calculations needed to do that. Furthermore, through this project, we were able to standardize some of our spare parts. Linear actuators are used nowhere else in our plant, but these gearboxes and servos are used in several other locations across our plant, and so that allows us to reduce the difference in parts we have in our inventory and keep more common spares, which is great for saving costs and reducing downtime and inventory space. Currently, this project, so where we're at with it now, is the AFC is fully approved. Parts have been ordered, but due to extensive lead times on the gearboxes, this will be installed after I leave, unfortunately. But all the drawings and technical information is there and complete and ready for our team to install it when the parts arrive. Next project, spill roll servo, AFCE 253406. I inherited this from a previous co-op, Matthew Martinez, who was a great mentor to me. So for this project, I designed the mechanical mounts and guarding. So the clevis mount on the back end of the servo, the arm that interacts with the actual spill gate on the spill hopper, that connects to the servo, the guarding on the top, and as well as the loading arm relocation for the scraper blade on the slate drum, making sure that we can fit everything in there. Yeah, a bit of background for this project. So currently our spill gate is manually operated with a set screw and a ruler. So operators have to manually walk over from their station and set the spill gate level between line speeds and product changes. So this, by automating this process, we will reduce the reaction time needed to change between line speeds, as well as increase the accuracy of granule application, because we're not relying on a set screw that's being turned manually and eyeballing on a ruler. So that'll be really, really great and save us a lot of money. I think the AFC is projected to save $200,000 a year. So that would be a really great one to implement. So unfortunately, again, due to extended lead times on the linear actuator, this project wasn't fully installed. However, in these pictures, I have what I installed so far. So during our November outage, I relocated the loading arm for our scraper blade assembly in the slate drum and installed the clevis mount onto the I-beams for the project. So on the first picture, that's the original location. The middle, we've got the the loading arm set out, and on the final picture, you can see the clevis mount tucked in there neatly for the linear actuator to go. And then when that linear actuator arrives, we'll get the guarding in place, get the arm installed, and have it, fully automated and work with our controls team to get that PLC programmed. Some additional tasks certainly kept myself busy. Not all these AFCEs are things that I wrote, but they're things that I may have assisted with, helping either manage contractors, work on drawings, work on small designs. So I reverse engineered obsolete parts for our maintenance team and made drawings for them. I also fabricated parts for them on our laser table when they needed them, especially, hey, we need wear plates for our bucket elevators. It's downtime. We need to get them welded. I go in there 6 in the morning, cut the drawings out in the laser table, and get them done. So yeah, we also worked on installing lights for the backup air and lighting AFC, as well as working with contractors to get the air lines installed, assisted with the implementation of the laminator de-stringers, assisted with the implementation of MyLube auto lubrication, helped manage contractors and pre-work for the packaging and line drive upgrades starting in August, and then Westrail replacement, helped manage contractors and get permits for that, as well as cataloged spare parts for our RTO. Yeah, here's some pictures of the additional tasks. On the left side there, that's the load cell we used in our split first cooling. I didn't have split. I ran out of room to list the split first cooling, but that was a fun one. Designed the cards for the cables for the load cell, as well as helped install the scraper assembly. In the middle there, that's the shim press assembly for the split first cooling. Helped Mark and Kevin get that assembled. It's pre-work. And on the far right there, that's the lights that I installed for the backup air and lighting AFC, which really lights up our homogenized area for operators to see valves. We have a power outage, and that's actually during a power outage, so it's bright, keeps it well lit. So yeah. Key takeaways. I learned a ton, so much more than I ever could have learned in the classroom. I learned project management, communication, scheduling, making sure that, hey, it's great on engineering's end, but is it good for maintenance? Is it good for production? Is it good for, where the line's at? If we, figuring out within specific downtimes, what mechanics are going to help you, what optics are going to help you, what contractors can you get in on site? When do they need to be on site? How long is the job going to take? All those things need to be accounted for. Failing to prepare is preparing to fail. So yeah, technical drawings and skills. Did a lot of drawings, a lot of Inventor, AutoCAD. Super amazing. Super happy to learn all that. Again, cross-department teamwork and communication, huge one, and thinking and working safely. There's no point in doing anything if it makes things unsafe or doesn't work out. We want to make sure that our operators and our maintenance team is safe. The equipment we install is as safe or safer than the new equipment or the old equipment, and making sure that, as we're working, we wear a proper PPE and keep yourself safe. You don't want to, accidentally get injured and not be able to get something done. So yeah, huge thank you to everyone I worked with: Mark Rosar, Kevin Prado, Marcus, Matthew, Arnold, Sean, Nick, Andrew. The list goes on. I mean, Chago, the mechanics, and Braulio and Junior and all them. So I really appreciated it. And like I said, the list could go on, and they really helped me and mentored me and say, hey, I see you're trying to do this. Let me show you a way in which, this might be better. Here's a way to help improve our aspect of it. It's great on, it looks great on an engineering drawing, but how does it look in practice? How do we maintain it and make those decisions based on that input? So yeah, I really appreciate it. It was all great. So yeah. And with that, that's the presentation. That's the end of the co-op presentation as a whole. I'm the last person. So if there's any questions, shoot them at me. So yeah.
Hi, Liam. My question is based on that absolutely wonderful comment that you made regarding a prior co-op serving as an excellent mentor. Can you expand on that a little bit and tell us what we found most valuable about that handoff so that we can learn from it? That was great.
Absolutely. Yeah. So Matthew, when I came in June, I didn't know anyone. I didn't know where anything was. You could have said, oh, I need you to walk around the FPL and look at this. Well, what's an FPL? Where's that? And so he took the time out of his schedule to show me every aspect of the plant, show me, hey, here's what this is. Here's what it does. If we'd walk by an operator, hey, hey, come over here. Hey, Jeremy, this is Liam. He's our new co-op, and introduce me to people. Hey, Braudel. Hey, Chago. Hey, John, Nick, this is Liam, and he would take the time to introduce me to people and show me equipment. And if I had any questions, I could go to him and say, hey, Matthew, how do I look for this in Maximo? I'm trying to find and see if we have this partner inventory. And he'd say, yeah, absolutely. And he would sit down and show me no matter what he was doing, when it was happening, where it was, he was always there to answer questions, show me what to do, and just provide a helping hand. So
That's so great. Thank you, Liam. I think it's a testament to both of you in working together. That's awesome. Thank you.
any more questions? Kevin.
Hey, Liam, I just want to ask, what would you say would be your favorite part of this experience?
Favorite part. I honestly got to say the coworkers. You know, working with Mark and Kevin and Marcus and Arnold has been absolutely amazing. Everyone's been super helpful. Any sort of questions, any sort of, hey, I need more help understanding this, or I have a AutoCAD question. Everyone's been super helpful. And then just after work, I mean, we, played pickleball together, went on rides. We did a lot of training actually before we did that 52-mile ride. So going on rides together and everything, it was just an all around upstanding experience with the people I worked with. So
Nice, man. I like that. Thank you.
any more questions? All righty. Thank you so much. I really appreciated the opportunity to have this experience with GAF, and I really appreciate,